All right. So now it's time to talk a bit about what a pod actually is. So in Kubernetes, the smallest deployable unit is not a container, but a pod. I've talked about this briefly earlier. It basically means that a pod definition may contain a single container, but there could also be multiples. So here it says a pod is a set of containers that will be deployed to the same Kubernetes node. All containers of a pod will share the same IP address, ports, hostname, may communicate via IPC, so this is possible, and share volume. I think they can also share multiple volumes. This implies that a different pod can be placed along with its containers on a different Kubernetes nodes. So when you define your workload, we will later see with replica sets that often you want to create multiple pods where each pod is very similar to each other, or basically it's the same, or they are equal. In this case, you would like to describe several pods in one specification, but tell how many of them you want to create. So this is what the replica set will do. And in this particular case, the pods may be located somewhere in the cluster. And as we know that the Kubernetes cluster consists of so-called nodes, Kubernetes nodes, this is where the workloads will be run. This is where the pods will be run. Not necessarily the pods will run on the same node. Where within a pod, there's one or multiple containers. And if there are multiple containers in a pod, they will for sure run on the same pod, and they will have the shared resources. They will have shared resources in a way that they can communicate using the loopback device, inter-process communication. They have the same host name, and they also share the same ports. So that means if you start a web server within a container, within a pod that uses port 80, then port 80 is occupied for all other ports in the same pod because they share the same ports. This is true, obviously, also for other IP addresses, because the pod, as we have seen in the describe pod example, also has a IP address that is bound to a network interface that allows communication to other pods. So each pod has an IP address, a cluster internal IP address. We'll also see that it is not very wise in most cases to use that IP address, because during the rescheduling of a container, for example, because the underlying node has been taken into maintenance, pods will fail and will be recreated, and subsequently the IP addresses will change. But it is worth mentioning that all the containers in the same pod will have the same IP address. So to be precise, we'll go back to the terminal. Currently we don't have pods, so let's create a simple pod. And there's our pod. And you can see that the pod has an internal IP address, and that this IP address is different from the one we've seen before. So the point is here, they will also share this IP address, and therefore they will also share the same port range. If you have two pods, they will have two different IP addresses, and therefore each pod has access or can bind to the entire port range. But the containers within a pod, they'll share the same pod range. So that's the takeaway here. You can also see that Kubernetes in this case, not necessarily, but in this case, also has a container ID starting with Docker, because in this case Docker is used as the container engine. You could also use other container engines, for example containerd, but in this case it is Docker. So it is basically running a Docker container within a Docker container engine, but it uses Kubernetes for the container orchestration. We've talked about the abilities of a container as means to isolate workloads from another. So we talked about having a database that has, for example, a Postgres database that has a Postgres database daemon, but also a replication manager and maybe other auxiliary processes such as a backup agent. So in this case, each database instance would run 3 different processes, and a way you could organize that is start each process in a container and all the containers within a pod. So this way they can share the resources necessary, because the cluster manager obviously has to talk to the database and vice versa. And the backup manager obviously also has to have access to the database. The way the pod shares the resources with its containers will be absolutely sufficient to do that. So as you can see, it will allow you to shield each process from another, in the way that if, for example, the backup manager leaks memory and starts consuming all the memory, the container will isolate that. It will also see that if the container process fails within a pod, that the container should be restarted. So there's a certain degree of self-healing applied to this. Or the pod will fail. I'll have to figure that out. So but then depending on how you deployed your pod, if we see that with the replica set, if you have a replica set, then the pod also will be self-healed. In the case that the pod fails, the pod will be recreated. Okay, so we've created that busy box pod. You can look at the pods, and there are different output variants, so to say. If you look into the kubectl documentation, you will see that white, for example, is particularly useful if you want to have more information without describing the pod, because there you can get a list of pods. So here you have, you're referring to the Kubernetes nodes. So this pod has been scheduled on this particular node. It has the internal IP address named here. So we can also use the JSON format. And you can see that this is even more verbose than the option wide. And as you can see, the output is JSON. So what the list you have seen above would be this array here. Now, why does this make sense? Sometimes, especially if you create shell scripts, you need to interact with Kubernetes, obtain a piece of information that's contained in the description, and you don't want to pass the text output, but you would like to have something that's machine readable. So for example, there's a little command line JSON parser that can help you filter out exactly the piece of information that you want. So you could, for example, take this output and then pipe it into JQ and filter your output. You will see that in many tutorials for more specific matters, and so this is what it's basically doing. It's using kubectl. That -o output is usable for most of the commands, I think, if not all, and then you can pipe that JSON output into a JSON parser. So this will help you to do fancy things just using the command line alone. So keep that in mind. And if you see JQ in a tutorial and it doesn't work, just ensure that you have JQ installed. So here, for example, brew search JQ. With Homebrew, you can just, install tools like that easily. If you're using Linux, you can do that, and I don't know how you can do that using Windows. You could use Cygwin or whatever.